today we want to talk about intermolecular forces. Intermolecular forces is very closely related to intramolecular forces, which we studied in first trimester. And it's so close it's sometimes hard for students to understand. So let's start with intramolecular. Intramolecular means they're bonds that are inside of the molecule. And we studied that when you have an ionic bond, you have materials that have swapped electrons, and then they become charged. One becomes positive, one becomes negative, and so they attract to each other. And they pull each other together very strongly and create a bond. And so like sodium chloride was an ionic bond. Materials from opposite ends of the periodic table, a metal with a non-metal. Those bonded together and created ionic bonds, okay? That's what held the molecule or compound together. Covalent bonding is when it was two nonmetals, something like oxygen and oxygen, or carbon and dioxide, CO2 and oxygen. So what happens is when they bond, they actually overlap, and they begin to share electrons in an inside orbital, and they covalently bond. So the sharing of electrons is another inside or intramolecular bond called covalent bonding. And metallic atoms, which is a form of covalent bonding, is when atoms get together and they share, and they get their atoms so close together they share all their outer electrons. And so that's the reason why metals will actually hold together. And so it's another type of intramolecular bond. So these bonds are found inside of materials, holding them together in very strong patterns, okay? And the reason why I want to mention those is because these ideas help us to understand the intermolecular forces. So we've been studying gases, and in our gases we've been studying balloons and containers that have these gas particles. Well, these gas particles do not want to come together. They're free. There's no reason to them to come together. They don't want to attach to each other. So gases are constantly compressible. They're free floating. They're random. If you had a cologne inside this balloon, you popped it, that cologne would move around the whole room. And so we know that gases don't want to be attracted to each other. But this unit is about why do we have liquids and solids? And the reason why we have liquids and solids is because now these particles are trying to get together and exist closer together. And as they get closer together, we then begin to find different states of matter like liquids and solids. So what brings them closer together? Gases don't want to come together. They'll keep spreading out. But liquids are attracted to each other, okay? Water will not let go of another water molecule, so it takes energy to get it to boil, okay? If you have a solid material, like plastic, they'll stay solid because there's an attraction pulling those molecules together. But that attraction is not on the inside, it is between the two molecules. So what is the force that pulls two molecules together? Now there may be other bonds inside that could be covalent and ionic, but we're going to talk about the bonds that bring two materials together that are called intermolecular. So, to talk about those, we need to talk about the three types of bonds. Ion bonds, which come from ionic bonds. These ions, like in sodium chloride, these bonds love to attract to their partners in ionic bonds, but that attraction is just not one direction. In fact, it attracts in every single direction all around. So what happens is, if I can draw a picture, we have our ion bond. So let's say we have sodium and chlorine, and they're attracted to each other. So here's my sodium and here's my chlorine. They're positive and negative. Well, this positive sodium is putting out its attraction all around. Well, another chlorine over here that's attached to a sodium is attracted to it because that ion force is still there, and then that attracts. And then what happens is we have another attraction down here for another material that was sodium chloride. They were bonded together, and then the attraction keeps going on and on and on. And so what happens is we get what's called a crystal lattice. We have a branching out of this charge. So here's my ionic bond, but that ionic bond attracts in all directions, and so it's an ion to ion intermolecular force that pulls the material closer together, and so those forces create very compact states of matter like solids and liquids. Okay, so ion to ion bond is a very strong bond. Sometimes they will also say crystal lattice. And what it means is that there is a repeating series of bonds. And so it's very common to find those in solids. And they're due to the extra forces that are now acting outside of the ionic bond to attract other ions. Okay? So it's between a salt particle and another salt particle. That's the extra little bonds. That's what we're talking about when we say intermolecular. Okay? So that's one type. It's the strongest type. Okay?